Are we on? All right. Hello, geometry students at Vertical Hills High School. Sorry you can't kind of see me fully all the way. Just trying to figure out this angle. I am going to be going over, I'm trying to make this video about 10 minutes. It's a goal, not a promise, okay? But I'm going to be going over some basics for your first exam in your geometry class. This isn't everything for the first exam. This is just the basics of it, so it's part of it. Maybe not even half of it, okay? But I'm gonna try to do this all in about 10 minutes or less. Let's see if it can happen. All right, I'm gonna give myself a task. I'm gonna try to draw a line. Okay, I might tell students sometimes, draw a line. They draw a line. It's wrong. That's not a line. Okay. The reason that's not a line is because a line, by definition, goes on forever. And since my whiteboard doesn't actually go on forever, I mean, I can do this and go forever. Try to at least. I'll get pretty tired, I think. Um, we show that a line goes on forever by putting arrows on it. So you probably so if I ever ask you to draw a line, that's how you draw a line. Now I may ask you to draw a line, but I want to name it. I want to say line AB. So I can write it. Now I didn't have to put the A here and the B there. I could have just as easily put A here and B here. That's perfectly fine. Sometimes you'll see just the A and the B just hanging out, floating in the air like that. Sometimes you'll see a point for the A and the B. That's fine too. This is still called line AB. I can also call this line BA. It doesn't matter. It doesn't change the fact that this line is this line. Now, how do I write that in general? Now, I'm not gonna, if I were gonna write a word problem for you guys, I wouldn't say, okay, draw line AB. I wouldn't do it like that. I wouldn't say line AB. I would do it like this. We would denote it. The notation here is like this. It's like a cute little mini arrow, and then you just put AB. That's the little notation for line AB. Now, I don't have to write it that way. I can also write it like this. BA. Because in this case, the order doesn't matter. I can say BA or B. AB. Doesn't matter. That's still line AB. So going back to what a lot of my students put down. They put down, if I say draw a line, they'll put down this. I say draw AB, they'll do this. Well, what is this? This is something else too, though. Though it's not a line, I want you to think of this as part of a line. So if I were to give you a whole line, a line, okay, and then I said, hey, I don't want the whole line, I want just this part of it. When you cut a line as part of a line, that is called a line segment. A line segment. You'll see us geometry teachers, a lot of times we'll just say segment. We're not going to say line segment. That's just us being lazy and using the shorthand of it, which is segment AB in this case. Okay, line segment AB. Now, if I were to go back to a regular line with arrows, line AB with arrows, you wouldn't be able to sit there and measure it with a ruler because it goes on forever, unless you have a forever ruler that never ends. Okay, but a line segment has a definite start and an end. Now, it doesn't matter. You could say segment AB, remember, or you can say segment BA. Doesn't matter, okay, in this case. It all means the same thing. We're still talking about that guy right there, AB or BA. And sometimes you'll see it like this. Sometimes you'll see it with points. Those are called endpoints. Endpoint A, endpoint B. Well, wait a minute, which one's end, which one's start? Really, it doesn't matter. They're both end points. You can end here or end here, it doesn't matter. Excuse me, so that's what they're called. So we have line, AB or BA, and then we have line segment, which we just call segment. Okay, moving on. If you notice, where am I writing all this stuff on? I'm writing it on a whiteboard, okay? I want you to think of a whiteboard. Think of a plane. This is what we're going to call a plane, not like a flying plane, but a plane like a flat surface, like a flat two-dimensional surface. Like this whiteboard is a plane. It's a two-dimensional surface, and I'm drawing two-dimensional stuff on it. Lines and segments and points. Okay, I'm drawing all this cool stuff on a plane. Think of it as a flat surface. Now I'm going to draw what a plane would look like. Okay, so if a plane would look like this, I can draw a line AB on this plane. Now, what would this plane be called? I'll give it a letter. Let's call this plane I'll go lowercase f. I can go uppercase R. Plane F, plane R. There's multiple. I could even call this plane A, I think. I think you could. It would be justified, right? But yeah, so this is what a plane is. Now, I can put another plane. Imagine this other plane. Kind of, sorry, I'm not very good at drawing. But I want you just to imagine this other plane kind of going like this, right? Not the same plane. So if I were to tell you segment RZ. Segment RZ, is it on plane? Oh, I can't use R. I've already used R before. Let's go PZ. Uh, segment PZ, is it on plane F? No, it's not, because line AB is on plane F. This dude right here, this segment is on this bottom plane. I'll call this plane, let's call it, what's a good letter? M. Sure. I'll go lowercase m. Okay. That is on plane F. That's what a plane is, just like kind of like a flat two-dimensional surface. Now, I want you guys to notice something interesting. You see this plane and that plane? They touch each other. In geometry, where do they touch each other? They touch each other right there. In geometry, when two things interact, when they touch each other, that's called intersect. They're intersecting in this case. They're intersecting right there. So when two planes meet each other, so it's kind of like saying, all right, let's take two pieces of paper. Let's see what happens here. Let's take two pieces of paper. This is a plane and that's a plane. I know it's kind of hard to see because it's white on white. Ah, that's better. It's a good thing I have a dark color shirt. If two planes intersect each other, look what happens. When they intersect, it's hard to see. When they intersect, right where they intersect, that forms a straight line. Okay? So when two planes intersect, they form a line. Now, it's important to keep in mind that planes also go on forever too. So think of this whiteboard, but it's infinite size. It goes on forever. So those are some basics. I know I said under 10 minutes, 7 minutes right now, but I still have quite a few more. So we have line, we have segment, we have points, we have planes. What if we did something funky like this? What if we drew a half line, meaning it goes forever one direction, it has an arrow, but I'm going to call this PT, okay? So it has an arrow going only in one direction. So it has one endpoint here at P, but then it goes forever on that. And again, you don't have to have the actual points there. Having the letters enough. What is this called? Well, this is called a ray. So this would be ray PT. And it's very simple. It's just as you would think. The notation for ray PT is instead of being an arrow, instead of being a line, it only has one arrow, and you would say P. But rays are interesting, and they're different for one reason. A ray definitely has a direction, whereas a line goes in both directions, infinite. I could say, if this was a line, I could say line PT. I could say line TP. It doesn't matter. But for a ray, you can't just say it any order you want. You have to go you have to say the letters, the points, in the direction in which the ray is going. So for this, I would have to say ray P to T. See, PT. I could not say ray TP because the arrow is not going this way. Okay, so keep that in mind. So this one, you'd have to say ray PT. Now, you see this little notation here? It confuses students sometimes because they're like, oh, I have to put the arrow this way because the ray is going this way. It doesn't matter. You always do the arrow going right. PT look like this. Let's say PT look like this. PT. This is still ray PT. Nothing different. The notation always still looks like this. The little arrow going to the right, and you say PT. It doesn't matter which way, even if it was going this way, ray PT. But be careful though, it would have to be P to T going that way. This would be wrong. Let me show you this. This would be totally wrong. You can't go T to P. See, that would not match that. Because what this is ray TP, because it goes from T to P going that way. Whereas this says it's supposed to go P to T. Well, I'm sorry, this ray does not go that direction. It does not go P to T. So it's based off the direction. So let's look at something interesting. Let's go on from that. What would happen if let's take a ray right now. I'm going to call this ray MP. Let's take one ray. Let's take another ray And oh, by the way, 10 minutes just passed on our video. I'm sorry. Let's add another 10. Let's make this a 20-minute video. I apologize. Okay, let's make this ray MP. But let's add to this ray. Let's connect another ray to it. And this ray we'll call MV. So I connected two rays at this vertex is what we're going to call it. Okay? And they connect at point M. They intersect at point M. We just created something new. We just created what's called an angle. We created an angle. Okay, this is not a huge angle. How do I know it's not a huge angle? Because it doesn't open up that much. Watch, this angle opens up about that big. Okay, it doesn't open up that much. It's a small angle. What would be a smaller angle? Well, what if it opened up only that much? What would be a bigger angle? Anything that opens up more. Of course, that'd be a bigger angle. So this isn't a huge angle. Okay, it's a smaller angle, but it's still an angle. Now, how do I name this angle? It's very important here in geometry. How do I name it? It's a very, very important concept here, okay? So volume's up to 11 here. I can name this angle a couple different ways. And just like with a line, we have the little, line AB, segment AB, ray AB. Just like those little notations that we have for line, ray, and segment, we also have one for angle. For angle, it looks something like this. It looks like a little angle symbol. How cute is that? Okay, so angle. But how do I say this angle? Well, I see here I have 3 letters here. Can I just say any letter I want? No. If you remember with a ray, okay, if I'm talking about ray MV, I had to say it in order of which it's going, M to V. Similarly with an angle, you have to tell me, you can't tell me, you have to tell me how to, think of it as this. Whenever you're trying to name an angle, think of it, how would you draw it? If I were to draw this angle, I wouldn't start with M, go here, and then connect here. No, I would draw it like this, starting from P, I would draw it, or I would start from V and go VMP. I would go VMP, or I'd go PMV. So either one of those works. So I'm going to do this. I'm going to say angle. Let's start with P. P, I'm drawing it. M, V. That is angle PMV. Well, that's not the only way to draw it. Another way to draw it is starting from the V. So I can call this angle VMP. VMP. There's another way to draw it. There's another way to notate this angle that we have right here. Okay, low key, there's actually one more way that we can denote this. And that is going to be, you just simply name just the vertex here. You don't have to mess with the P or the V. You just simply say angle M. Now you may be saying to yourself, wow, that's the easiest one, just angle M. Why don't I just do that every time? Angle M, boom, easy. Well, here's the catch. Though that seems legit, that seems like a great way of naming it, because angle M is very clear to me. That's we're talking about this angle. Sometimes it's not that clear, and let me show you why. Okay, so I am now going to do this. What if I did this? Okay, that's good. That's the M, right? Extend this out, put another ray here, and let's call this, no, let me go like this, put another ray here, and I'll call this, okay, so here's the problem now. If I were to tell you angle PMV, that's very clear. We know what PMV is. PMV is, I'm just going to trace it, PMV. That is very clear, no question what angle I'm talking about. I'm talking about this angle that goes PMV. Cool. But in this scenario, if I were to say, tell you, hey, angle M, the reason that is so confusing, you can't just say angle M in this situation, because you might be saying, oh, angle M, yeah, I'm talking about this one. Are you sure about that? How do I know you're not talking about, how do I know angle M, you're not talking about this one right here? I don't know that. You want me to just assume which one you're talking about? How do I know angle M is not this angle right here? Okay, I'll take it one step further. One second, okay. How do I know angle M isn't talking about this entire thing right here? Boom, 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 this whole angle right here, going from PM and Q, or I can say from QMP. How do I know angle M doesn't mean this whole thing? I don't know that. You want me to assume it? As a student, as a teacher, you want me to assume I know what you're talking about? I don't know that. So for that reason, you can't always just use one letter when it comes to that. Doesn't always work. Let me show you another example. Okay? So let's say you have a triangle. A tri meaning three, angle. Well, a triangle is this. I'm going to call this triangle ABC. Okay? A triangle. Well, I could say angle A is equal to 71 degrees. Do you guys know what angle I'm talking about when I say angle A? Yeah, probably you do. Angle A is this dude right here. It's the only thing that can be angle A. That is 71 degrees. Cool. I could say, oh, by the way, the reason you would note this, you wouldn't just say angle A equals 71 degrees. I mean, you could, but normally you would say the measure of, if you're going to give me an exact measurement of an angle, you say the measure of angle A. And the way we denote that is we go M. That little m means, the way this is read is measure of angle A equals 71 degrees. I'm going to give you another one. Measure of angle B equals 32 degrees. Measure of angle B equals 32. So what we normally do when we have an angle measure, we put it on the inside of that angle. So 32 degrees, right there, okay? So that's how we write measurements. Now, when I'm talking about angle A, this angle right here, I don't have to just say angle A. Another way I could say it is angle, let's see how we would draw A. We can say BAC. Or if I'm still talking about angle A, another way to say it is to say angle, maybe start it here, CAB. Okay, because if I do CAB, I draw angle A. If I do BAC, I'm still drawing angle A. This is where it's very helpful to do with a highlighter even, you know what I mean? But I want you guys to notice something. Whichever way I say it, whether I say angle A, whether I say BAC or CAB, you'll notice always in the middle is always that angle A. That vertex of that angle is always going to be that middle letter right there, that middle point. It's always going to be the A. Okay? Hope that makes sense. All right, we're almost running out of time, so I want to fast forward a little bit more. Talking a little more about angles and degrees of angles. If I get two A's, you guys have probably seen this before. And, you know, I usually put the angle measure in here. What if I put an angle measure of that? I don't actually put a number. I just put a little box there. I'm sure many of you have seen this before. That means that that angle measure is 90 degrees. In geometry, you're not going to see us write down 90 degrees. We're not going to put that down. We're not going to put the number 90. We're just going to put that box there. This is called, but it is 90 degrees, okay? This is called a right angle, which is, again, 90 degrees. All right, anytime you see a box, it is 90 degrees. So what do we call it if it's less than 90? So right now this is 90 degrees. Now if it goes less than 90, well, what's less than 90? Well, how about, I don't know, I'm just going to give any number here. How about 34 degrees? Now, is 34 degrees less than 90? Yes, it is. And the way I like to remember it is, look at that little angle. It's so cute. It's so cute. It's so cute. It's so little. That is a cute angle. Get it? A cute angle. All right? That just means acute just means it's small. Okay? Smaller than 90. Any number smaller than 90. So what if I did this? I'll draw this angle. It looks like it's 90, doesn't it? But what if I don't put a box? I say this is 89 degrees. I know it looks really close to 90. But what if I tell you that's 89 degrees? That is considered acute. Why? because it's less than 90. Anything less than 90 is considered acute. Okay, so back to the 90 degrees. So now this is 90-degree angle. What if it is not smaller than 90, but greater than 90? So let's try something like this, greater than 90. So let's go something like this, 120 degrees. Simple. If it's bigger than 90, greater than 90, this is called obtuse. Okay? I like to think of it like obese, you know? I don't know why, obese, you know, like big, you know? So obtuse, bigger than 90. I don't know if that's the right way, that right etymological structural analysis or anything like that. I have no idea, but I'm just saying bigger than 90 is going to be 120. It doesn't have to be that big. It can be just 91 even. Okay? If it's just even slightly bigger than 90, just 91 degrees, that is still considered obtuse because it's bigger than 90. Okay? And what you're going to see for the most part in the beginning of geometry, what if I have one that opens up? So let's say this is, if I draw the line up here, that's a 90-degree angle. 91 degree, 92 degree, 93 degree. I go 100 degree, 120 degree, 130, 140. I extend this angle so much, it opens up so much that it basically opens into a straight line. Think about this. What I did is I took this angle like a mouth, like Pac-Man's mouth. I opened it up so much that it basically became a straight line. Well, how many degrees is that? I want you to think of it like this. Imagine having a 90 with another 90 right next to it. 90 plus 90 equals 180 degrees. Okay? So what we're left with here is a straight line. So whenever you have a straight line, that is 180 degrees. And guess what the name for a straight line is for an angle like that? You guessed it. It is called a straight angle. A straight angle is basically a straight line, right? And a straight line is 180 degrees. Okay. So now, I'll throw out one last question. I'll throw out a question for you guys, and then you guys will be pretty much done. Speaking of angles one last time, let's say I give you something like this. I say angle A, B, C. And I'm going to go here and say this is, I don't know, Q. And this angle right here is 37 degrees. This angle right here is 55 degrees. Okay? So, angle ABQ is this guy right here, 55 degrees. QBC is 37 degrees. Here's my question. Is angle ABC acute, obtuse, or right? So my question I want to know is angle ABC, and the first thing I would do as a student is I would trace that. I would go ABC, okay, I got you. A to B to C. ABC. So I'm talking about this whole angle. We're talking about this whole thing. So I want to know if this whole thing is acute, obtuse, or right. Well, right means 90 degrees. Okay. Anything less than that is acute. So, but the thing is, this entire angle is composed of two separate angles. There's two separate angles. So how do I know what the whole angle is? Simple. You got two things that add up to one big thing. Add them up. So I'm going to add up 55 and 37. So 55 plus 37 is going to give me 92. So I know, I'll erase this to make it cleaner. The whole big angle ABC is 92 degrees. And if that's 92 degrees, I know that's bigger than 90. Bigger than 90 means obtuse. Okay? All right, we made it under 25 minutes. I apologize, but that's a lot of what you already need to know for test one. Thanks, guys.